So say you are building a ground-mounted quarter-wave vertical for the 40-metre band, but the pole that you are using is only about 9.4 metres in length. Now this is a very common problem that radio amateurs come against. When you actually buy a 10-metre pole, typically they're not 10 metres, they're a little bit less. Now you could go bigger and say get a 12-metre pole, but then remove some sections. That's one way to do it, and I've done that in the past. But I wanted to use the DX Commander Signature 9 poles. The 12-metre poles were just overkill for this. So my Signature 9 pole is about 9.4, 9.45, maybe a little bit longer if I pulled it all the way out. Now, a full-size vertical for 40 metres is in somewhere in the region of 10 metres. So we're about 40 centimetres short, okay? So there's a number of ways we can actually electrically shorten the antenna, and that's what I'm actually going to talk about today. So I'll tell you how I'm going to do it, but I'm going to talk about another couple of methods first. So when I first got licensed way back in 2011 or so, I used a method called helical winding. Now, if you don't know what that is, it's basically like what a corkscrew looks. So you basically wind the wire gently up the pole. So you're not winding it tightly, you're just taking some, you're just winding the excess wire around the pole kind of evenly all the way up. Think of it a bit like a helter-skelter, and that method works really, really good. But if you want something that's really repeatable, like if you're going out portable, that can be kind of time consuming because the antennas that I'm talking about have to be identical. So resonance, it matters to me a lot, and I need them both exactly the same. So that's not a method that I would go with. Another method is linear loading. So that's where we run our wire up the pole, we come across a little bit and come all the way down. Now, I've done this a number of times and with great success, but what really matters is the distance, the horizontal separation between the two wires before it comes back down, because the narrower the separation is, the more wire you have to run back down the pole. And again, that wasn't something I was wanting to do when I was going to put these up repeatedly for temporary operations. I needed it really repeatable because remember, we wanted to have a resonance point that was the same every time. Now that gets us onto our third method, and that's using a loading coil. Nothing new. You can put your loading coil in a number of places. You could put it at the bottom of the antenna, the middle, the top, wherever you want it. Now there's a lovely little calculator by M0UKD, and what you can do is you can just put in your dimensions of where you want to put the coil. So in my instance, I put the coil 4.5 metres from the ground, and then for the remaining length of the 9.4 metre pole, we just run the wire all the way up. And the beauty of doing this is you just need to wrap the wire around a former. Now I used a PVC waste pipe, which is incredibly cheap. Again, this is a temporary antenna, so I'm not worried about UV resistance in the slightest. So I put those numbers into the calculator, and it came up with a figure. Now around my 40mm former, it worked out to 8 turns. Now, once you use this M0UKD calculator, it'll give you a figure in microhenries typically of inductance that you need to wind onto your element. Now there's another calculator, another website called the 66 Pacific, I think it's called. And basically you can put the diameter of the former, the type of wire, sorry, the distance of the windings, the diameter, and it will give you a pretty accurate dimensions that you can actually wind your coil to. So that's exactly what I did. But I actually have an LCR meter, the Peak Atlas LCR 45, which is an amazing bit of kit. So I can get this coil just absolutely cock on. So what I actually did was I actually wound a dummy coil just around a piece of this PVC pipe, and I calculated that I needed 8 turns is what I needed. So that's what I did. So then I took my length of wire, which was about, I think at the time was about 11 metres, the full length. So at the 4.5 metre point, I simply wrapped the wire 8 turns around about it, cable tied it in place, and then ran the antenna up to the top. Now, I still needed to do a little bit of trimming, and that was okay. So what I did was I then just looked at my antenna analyzer. Now, when you're using your antenna analyzer, VNA, whatever you're using, remember to null out your coax that you're using, so you're only measuring the resistance, sorry, the resonance right at the feed point, so that creates a plane. So we're not taking any of the coax into account, okay? So that's what I did, and I ended up just trimming off just, I think, about 10 or 15 centimeters, and that actually brought the coil, the antenna with the coil into resonance, and it brought it down to about 36, 37 ohms, and the SWR was about 1.3 to 1, something like that. So ideally where it should be by design. No, I was using quite a lot of verticals here. There was probably in the region of equivalent of 20 quarter wave verticals, but I had them cut into bunches of 6, and each of those wires was 4 meters long. So there we go, guys, just a little hint on how you can actually shorten your antennas. Now, this antenna was only shortened about 6%, and in the grand scheme of things, that's really not going to make a big difference to the efficiency of this antenna. I'm going to lose a little bit, but it's going to be nothing to speak of. So now I need to repeat this experiment with the second wire, because I'm going to be building a pair of phased verticals. So once I get the second one built, I'll get them both up, and I'll then get them finely tuned, and then hopefully we will have a working antenna. Alright guys, 73, we'll catch you on the next one. Bye for now.